Hello everybody, I'm so happy to see you in the third part of this course. So today we have pre-processing with Matlab, and if you have this question that why we need pre-processing, I will tell you that there are just some functions that you need to prepare your images for your processing phase. Here I'm going to just introduce some functions to you. However, pre-processing is not limited to these functions, and maybe you need other functions, maybe you need other operators, maybe you need other pre-processing techniques that you can apply them by a code that you can write. However, this is just introductory, and in future episodes, if we need some other works on our images, we will write a code, or we will introduce you some other techniques that can be helpful. So no worries about that, but just let's start with these functions and a little work with some images. So the first, I can again open an image, so I name it I, so it will be in read. So for example, it was kid.jpg, and I show it again as always. All right, so this is our image. I want to change it to a gray image. In this case, you will see the differences better. Plus, we will have one episode just for color imaging and image processing. So here I say I equal to RGB to gray I. All right. So if I show it again, you'll see that this is like this. So the first function that I'm going to show you is im add, like this. It is image add, so it will add some values to every pixel of your image. So here it's better that we go to Matlab documentation and take a look at the function. I should tell you that documentation of Matlab is pretty interesting, pretty clear, and with very amazing examples. So always it is preferable to go to the documentation and check the function and see how you can use it in the correct way. So here you see that you have im add x and y. All right, so you need either two images, either an image and a value. All right, so let's say I1 is equal to im add I and for example 50. All right, and here I show I1, and you see that it is pretty brighter, this image. If you want to compare your images together, you can just say you can use just subplot we say 1 and 2 and 1. The first one, in fact, two elements, stays for the size of you know, the showing matrix, okay, that you are making. So it is 1 by 2, one row, two columns. So one row, because I want to show the images in one row, two columns because I want to show the original image and the changed image beside each other, and one means the first image. And you write again im show I1 I. All right, and you just need to copy, paste, and just change the second element, change this element to the second element of the showing window. All right, and image I1. So if you show them, you see both images beside each other. So you saw that here imAdd is adding a value to all pixels. All right, every pixel has been changed by this constant. All right, so let's go to another function. We have im, so I can just replace it with I1 here. We say im subtract. Im subtract reduces this value from your image. Okay, so in this case it will be like this. It is darker. All right, so I can show both of them again beside each other. All right, you see that 50 values have been reduced from each pixel, so the image, the result is darker. Also, you can use im multiply and im divide. Okay, instead of adding and subtracting, it uses multiplication or division. All right, so let's try that. So let's go to this one and I say im divide I, and just like 3, for example. All right, and see the result. You see that it is pretty darker again, and much more darker. How much the effect is strong. An opposite to this, so it can be im multiply. So I change this part, multiply, sorry, im multiply I and 3, and if you show it, you will see that it is pretty brighter. All right, so these are just some functions that you can use them for your photos if they are pretty bright or pretty dark. So with this you can a little bit modify the intensity of the values. However, next one, we want to have a look at the logical operators. The first one is bit and. All right, so for example, I write b equal to bit, and again we need to input images to use this operator and between the images. So we will have, for example, I and I1. All right, so the result of bit and, of course, is the common parts of the two images. Okay, so let's show the original image and the result. All right, you see the result is like this. Or we can use bit or for I and I1. Okay, and show the result. So it is like this. Next one we can try bit XOR, and I missed the T, so I execute and I show the results, and you see it is like this. All right, for example, you see that XOR has worked like detection for, you know, edges. Okay, it is pretty interesting. Okay, so however, in future you will see that how you can use these functions for the application that you need. Next function is resize. that is pretty functional and pretty important, really, to use in our works. So if I want to show, for example, on uh, on a slide, we can say, for example, like this: if you have just these pixels, all right, if you want to resize it, or I bring this one, okay, just I try to be quick, okay, this and this, and just if I can change them to simple look, it will be great. All right, so for example, you have these this small image, okay, and you have a values like 1, 15, and 2, and for example 0. All right, and you want to resize your this photo that is 2 by 2 to a photo that is 4 by 4. What will happen? So you have a pixel here that is 1, you have a pixel here that is 15, you have 2 here, you have 0 here. But you see that how many pixels here you have that they need to be filled. And for this is you know, something that Matlab does for you, and by interpolation and other techniques completes, okay, and builds these pixels for you, and the result will be a bigger image. All right, so let's go back here. So let's see the documentation for resize. So you see that you have these functions, and either you can have one output that is your image, the resulting image, either you can use it with two outputs. And here is all the description that is pretty simple and easy to follow. So for example, let's use it on our image, that is image I. For example, I say im resized, im resize I, and for example 1.3, a little bit bigger. All right. Oh, I had a little problem in the writing. All right, so now let's show for showing, in fact, it is not clear the result. However, if I show it, you see it is the same image. The quality is pretty still good, but the size, if you come and compare here, you see that I is 660 by 660. However, here now you see that it is after resizing 858 by 858. All right, this function for resize, and the question is here, if you want to make it smaller, what you should do. So it's easy, just here you use a digit, you know, a number smaller than 1. All right, for example, if I write I and 0.3, so the result, you see, that is 198 by 198. All right, so this for im resize. Next one is im rotate. Okay, if we want to rotate our image, we say I to im rotate I, and what can be there? The angle. All right, so for example, you write 90. Okay, and im show, let me come back to this function, im show I2 also. All right, you see both images and the one that is rotated. This for im rotate. Okay, and now you are getting habituated to the functions of Matlab, that they are pretty easy to guess. So next one is imcrop, that cuts a part of the image for you. So let's see the documentation first. Here you see just imcrop without input. In this case, it uses just the image that is already read or shown, and then you can manually crop it, or you call another image, or you can call the image and give it a map, okay, or a rectangular to cut the image for you. So we can try it. For example, here you write I3 im crop I, okay, and this will be open for you, and the part that is a region of interest for you, ROI, you can just choose it manually by clicking, keeping it, selecting the area, and double click on the area. All right, I3 has been saved, and if I show it, you see this is the part that has been cropped. Or you can just if you want to use it in a code and automatically crop a part of the image for you, so you just need to give it the address of the rectangle. In this case, we say I, and so here what you will write is like this, okay. So I delete this here. All right, so I paste it here. Okay, let me make it bigger for you. All right, so it is like this: im crop your image, and in brackets you are going to write the address of X, the address of Y, and the width and the length of the rectangle that you want imcrop to cut for you. Distance, I mean one space, and length. All right, so the example will be like this, or just all of it, or just come back to MATLAB. For example, you write like this, okay, pixel 10 and 10, the width of 50, and the length of 100. All right, and we will show it. So you see it is like this. I don't know if you see it or not. Let me little move it, then it will be clear to see maybe. Okay, this is the part, or if I make it a little bigger, this one I change to 150, this one I change to 300, and in show, this part of the image has been cropped. All right, so this was how to use imcrop also, and take some of your image and prepare it for processing. Imagine that if this is like a fruit or something, you can just cut the fruit. Or if it is an image with for example a car, you can just cut the number of the car, and you know, find a car that has passed a red light or something. Okay, so next function will be flipping the image. So I say for flip left right. You see, flip LR is left right. So it mirrors the image for you horizontally. So if we show both of them, I4, you see that horizontally it has been mirrored. And if you want to do this just vertically, you use up down, UP, UD, yes, up down, and show before, and you see that your image has been flipped upside down. All right, this just a little introduction to some of the basic functions for preprocessing. And in next video, you will see some more interesting functions for processing the images, and we kind of start analyzing the images. So it will be pretty interesting for you. I propose you to a little play with these functions that we had in these two episodes, and you will be prepared for the next one. See you soon.